This is a flavor of test 1, test 2, and test 3. So let us go ahead and start. So the first question is draw the graph or draw the angle in standard position. So you have 315 degrees. So when you look at this 315 degrees, obviously it should be in D, okay? Why D? Because from here to here, it is 180, right? So 180, this is 270, and you need a little bit of that to have 315 degrees, okay? Question 2 says, find the length S of the arc of a circle of radius 14 feet, subtended by the central angle half radian. So we know that the arc length is given by S, radius multiplied by theta from your table. Our radius is 14 and the angle is half radian, so this is 7 feet, right? Okay. In question 3, we have find the length S of an arc of a circle of radius 5 feet and the central angle 33. So the difference between 2 and 3 is that in 3, your angle is in degrees, which needs to be converted to radians. So again, S is radius multiplied by theta, where the radius is 50 multiplied by the angle is 33, but it needs to be converted to radians, so we multiply by pi over 180 degrees. Okay, when you put this on your calculator, you should get something like 228.798. Why 798? Because the instruction says 3 decimal places. Okay. So again, if you want, when I mention, for example, say question 4, you can pause the video, work it out, and then check the answer. Or if you want, you can just go through and then revise later. Okay. So in question 4, we want the area of a sector of a circle of radius 100 feet formed by the central angle of half radian. So recall that the area is given by half radius squared theta, where theta is already in radians. So this is 1 over 2 multiplied by 100 squared multiplied by 1 over 2. Okay, so this is just 1 over 4 multiplied by 100 squared. Okay, and when you expand this on your calculator, you should get 2,500 square feet. Okay, I will do question 5. So in question 5, we are looking for the looking for the area of the lawn that receives the water, where the radius is 40 and the angle is 125. So 125 is in degrees. It has to be converted in radians. So in our formula, area is equal to 1 over 2 r squared theta. We write 1 over 2. The radius is 40 squared multiplied by, so where there is, for theta, I write 125 multiplied by pi over 180 degrees, right? So why did I multiply by pi over 180 degrees? Because the angle is in degrees. We have to convert it to radians. So I already have this on the calculator. So this is 1,745. Correct to 2 decimal places, it will be 0.33. Okay. A point, right? So a point P, which is a point on a unit circle. Okay. So if this is the unit circle on the right here, I will draw something like this. Okay. And this is negative, comma, a positive number. So your point P should be somewhere here in the second quadrant. So if this point is on the unit circle, it means this is x comma y, right? X comma y, which is in the second quadrant. Okay. So if that is the case, so we know that x is cosine theta, which is theta is t in our case, and y is sine theta, right? So sine t in this case is just the value of y, which is 1 over 2. Then cosine t is the value of x, which is root 3 over 2. Okay. And then tan t is just that ratio. So I take 1 over 2 and divide by, right? I divided by negative root 3 over 2. This is just 1 over 2 multiplied by, negative 2 over root 3. Okay. So 2 and 2 cancels. I have negative 1 over root 3. And if we rationalize this, right, multiply the numerator and the denominator by root 3, this becomes root 3 over 3, the negative. Okay. So that's it, right? Okay. What about cosecant? So we know cosecant is, so cosecant t is 1 over sine t. So the reciprocal of sine t is 2, right? Okay. Then secant t is 1 over cosine t. This is just negative 2 over root 3. When we write it in rationalized form, we have a negative 2 root 3 over 3. Okay. Then cotangent, we just look at the value for tangent, so which is cotangent t. Let's see, cotangent t is 1 over tan t, which is negative 3 over root 3. And if we rationalize this, we get this is 3 root 3 over 3. So 3 and 3 cancels, we have root 3. Okay. In 11, you have sine theta is given by that, cosine theta given by that, right? So here you're just remembering your reciprocals. So cosec theta, as in the previous example, is 1 over sine theta, which is, so 1 over sine theta, just take the reciprocal of that, so which is 16 over square root of 255. Okay. And if I rationalize this, so by rationalizing, if you have forgotten, multiply the numerator by what is in the denominator, so that we take rid of the square root, 255. So this gives us 16 square root of 255, everybody over 255. Okay. All right. So in the same way for secant theta, we have 1 over cosine theta, which is just 16, right? Okay. What about tan theta? So we know that tan theta is cosine theta, which is sine theta. So 255 over 16 divided by 1 over 16. Okay. Then I take the reciprocal of that, 255 over 16 multiplied by 16 over 1. So 16 and 16 goes. I remain with the square root of 255. Okay. Now, cotangent of that, so cotangent is 1 over the value for tangent, right? So the tangent is square root of 255. So if you rationalize that, you get the square root of 255 divided by 255. All right. So in 12, we want to find the exact values of the remaining trigonometric functions, given that sine theta is 7 over 25 and our theta is between 90 and 180. So let's put this on a unit circle. Okay. So 90, 180 is in the second quadrant. Okay, so let's say this is our theta. So because sine is opposite, so the length on the opposite side here is 7 and the hypotenuse is 25. So meaning that we will look for the adjacent, which maybe I can call A. Okay. So A squared is given by the hypotenuse squared minus 7 squared, right? So this is 576 A squared, so that A is just 24. Okay, so while there is A here, I put 2, 4. All right. So if that is the case, then we will say that cosine theta is, so cosine is the adjacent, right, over the hypotenuse. And we are in the second quadrant, so this is negative 24 over 25. Okay. In the same way, tangent is opposite. So in the second quadrant, we are negative. So negative 7 over the adjacent is 24. Okay. All right. So cotangent is just the reciprocal of the tangent. So this is just negative 24 over 7. Okay. What about secant? So secant is the reciprocal um of cosine. So this is just negative 25 over 24. Okay. And cosecant is the reciprocal of sine. So this is just 25 over 7. Okay. So you are done. So given the equation or the function y is 6 sine 1 over 6x. All right. So let us find the domain, right? So I mean the domain of this kind of a function is just from negative infinity to infinity. Okay. And the range, obviously, because the amplitude is 6, so the range is with close parentheses, negative 6 to 6. Okay. And then at least we may need to find the period. So the period denoted by P will be 2 pi divided by the coefficient of x, right, which is 1 over 6, so divided by 1 over 6. So this is 2 pi multiplied by 6, which is 12 pi. Okay. All right. So since that is the case, if you draw your graph, it should look like this. So it will pass at 0, and then let's see. So it will pass at 0, goes to 6, goes down here, and yeah, it should be all the way to 6, right? I mean, since I'm using the computer, it should be easier to draw. Okay. All the way to 6 here, and then something like that. Okay. All right. Okay, so in the same way, 15, the domain is negative infinity to infinity. The range is negative 3 to 3. Why? Because the amplitude, right? The amplitude here, amplitude is 3. So the range will be negative 3 to 3. Okay. So in the same way, we can compute the period, right? So the period is 2 pi divided by 1. The coefficient of x is 1. So this is just 2 pi. Okay. So if I draw my graph, it will just be something like this. Um, let's see, it just be something like this. Okay. Something like that, right? Then I do, let's see. I think right, to be like that. I mean, this is symmetric, so it should be like that. Yeah, it should be like that. Then I think it will pass at 3 and yeah, and drop at 4, something like that. Okay. Okay, so you have that function. So the amplitude is 5, obviously. Then for the period, we may have to do one more thing, right? We write this function in this form. So 5 cosine. So we factor out the 3, remain with x. This is plus pi over 6, right? When we factor out 3. Okay. So right. So having written it in that form, I mean the amplitude should be like we have 2 pi divided by 3, obviously. Okay. And then I wrote this equation, I mean the function in that form so that I extract the phase shift, which would be negative pi over 6, right? Okay. So if you don't write it in this form, you may be tempted to think that the phase shift is negative pi over 2, right? But x has to be the quotient of x has to be 1. So we factor out 3 so that we have pi over 6. Okay. What about here? So what this implies, right? It implies sine theta, right? Sine theta is equal to 0. Okay. Sine theta is equal to 0. So the question is, what theta do we need to get 0? I mean, obviously theta here is what? Is 0. Okay. So this thing is 0. Okay. So write the left side in terms of sine and cosine, right? So I mean, we already have sine here, right? We already have sine here. So what is in the parentheses here? Cotangent is cosine theta divided by sine theta plus tangent is sine theta divided by cosine theta, right? That's it. Then the next thing is to uh, simplify inside the parentheses in this previous step, right? So to simplify that, the common denominator here is sine theta cosine theta. When we divide that, we have cosine theta squared, right? Plus sine squared theta. I mean, that is 1, right? So this is just 1 over sine theta cosine theta. Okay, that's it, right? Then simplify the expression from the previous step and write the result in terms of theta. So remember, outside we have sine theta, but we are multiplying 1 over sine theta cosine theta. So sine theta and sine theta goes, we remain with 1 over cosine theta. Okay. All right. And then, so the question says, okay, so in here, the fraction from so in here, we end here, right? Now, the fraction from the previous step simplifies to second theta. When we simplify this further, we get second theta. So the question is, what do we use to get that? Obviously, it's the reciprocal identity. Okay. Okay. So here you have to remember from your trigonometric table, right? So you can look at 35, 35 and 10 looks like 45, right? So this is just cosine 35. There's a minus here, so this is plus 10, right? So this is cosine 45, which is root 2 over 2. Okay, that was simple. Okay. Okay. So in 42, when you look at your trigonometric table, right, you will realize that there is a formula that has this kind of thing, right? Okay, which has this kind of thing where you can see this 9 theta, right? This is 9 theta and this is 18 theta. I mean, this 18 looks like 2 multiplied by 9, right? So this is where this thing comes from. So if you have cosine theta plus theta, right, which is 2 theta, but if you expand this, it will be like cosine theta, when I just see this, it's just cosine, right? Then minus sine theta. Okay, and this is, as I said, this is cosine 2 theta is equal to, this is cosine squared theta minus sine squared theta. Okay, so you can see, obviously see that this is the same as that one, right? So in this case where there is cosine 2 theta, I write this cosine 1, I mean cosine 18 theta. So cosine 18 theta can be written as, um, write it down here, can be written as cosine 2 9 theta, right? In that order. Okay. So if that is the case, then I can just expand this, right? This is just cosine squared 9 theta minus sine squared 9 theta. Okay. So I'm just applying what I wrote here, the original formulation. This is what you see on the table. Okay. So if that is the case, then we are in the case of D, right? This is what I was just doing here. So we started from the right. This way. We have cosine 18 theta. I write it in the form of cosine 2 multiplied by 9 theta, which expands to this. Okay. So we want to find the distance of AC. I mean, obviously, AC is the opposite of that angle, and we have the adjacent. So we go ahead and use good tangent. So tan 35 is the opposite, is AC. The adjacent is 200. Okay, so therefore AC is 200 multiplied by tan 35 degrees. Okay, and this is 140.0415, which rounds to 140.04. That is to 2 decimal places. Okay. Okay. So in 50, we are looking at how far, right? How far is the ball from the center of the green? So we're looking for this distance here. Okay. So that is the opposite of that. So let's call this distance as A. Okay. So what are we going to use? We need to use the cosine rule or rule of cosines, whatever you want to call it. All right. So let's see. So we're looking for A, so we know that A squared is the sum of squares in the sides from the angle, right? So we have 45 squared plus 150 squared. Then I subtract twice the product of 45, 150. Then I multiply by cosine 100 degrees. Okay. So if that is the case, then this implies A is, so I'll just take the square root of this whole thing, right? Let me write it down here. I want to create space. A is the square root of this long thing. So I'll just go ahead and punch this on a calculator, right? 45 squared plus 150 squared minus 2, 45, 150 cosine 100. Okay. So remember, when you're putting this in a calculator, just write the way it is, right? 45 squared plus 150 squared minus. So this is a product, 2 multiplied by 45 multiplied by 150 multiplied by cosine theta, right? If you confuse these, you may end up getting the wrong answer. So if you if you punch this in a calculator, you get something like, let's see, this is like 163.918, which rounds to 163.9, right? To one decimal place. All right, question 15 looks good also. You know the area of this kind of a circle of a triangle is 1 over 2, the product of the two sides, right? So this is 4 multiplied by 5, then I multiply by, let me write this again, 1 over 2 multiplied by 4 multiplied by 5 multiplied by sine 90. Okay, so you can just check from the formula. Okay, so this just looks like 1 over 220. This is 95 actually. Sine 95. So this gives us to two decimal places, this gives us 9.96. Okay. So 52 is the same flavor as 51. The only difference is that you don't have any angle here. So remember, you will need to calculate the value of S, which is 1 over 2 sum of sides, 4 plus 6, 10, 17, right? So this is 17 over 2. All right. So if that is the case, then the area, let me create more space. The area denoted by K is the square root of 17 over 2, 17 over 2 minus 4, 17 over 2 minus 6. So I'm going to take the square root, 17 over 2 minus 7, right? So this is under the square root. Okay, something like that, right? So I have 17 over 2, then I subtract each of the sides from 17 over 2 and take the product, okay? So if you do that, I mean, if you want, you can just punch the whole thing on your calculator. You should get something like 11.98, right? 11.98. That is to two decimal places.